All right, here we go on page 3. Numbers 20 through 24 say, use a calculator to approximate the measure of angle A, round answers to the nearest, to 1 decimal place, When we're finding the measure of an angle, this is where we use our inverse trigonometric ratios. Okay, they're saying that the sine of A is 0.83. Oftentimes we'll have some fraction for sine of A. So we'll say like sine of A is equal to opposite over hypotenuse. It could be like 3/5, something like that. Well, they've already put it in fraction form for us. So the only thing we need to do, if it had been, let's do that example. If it had been sine of A equals 3/5, then to find the angle measure, we would have done sine inverse of 3/5 in our calculator, and it would tell us whatever that angle measure is. Let's find it just for fun. Make sure you're in degree mode. So that means down here you've highlighted degree, that's lit up. If it's not lit up, you need to make that change in order to get these correct. So to use sine inverse, this little guy above the sine button, we're gonna go second sine, and then I'm gonna do 3/5. Now this wasn't a problem in your review, it's just one I'm trying out, I'm making it up. It's giving us 36.869 stuff, right? So if I'm rounding to the nearest tenths place, I would round up to 9 because that's 6 or greater. So this one would be about 36.9 degrees. Okay, like I say, they've already taken this and put it in a fraction. Or sorry, they've already put it in a decimal from a fraction. So all we have to do, it's actually quite easy. We're gonna take sine inverse of 0.83. How do we know we're using sine? Because they told us sine from the beginning, that sine is this, and they want an angle measure, so we're going to use sine inverse. So in my calculator, I'm going to type sine inverse 0.83 and hit enter. If I'm in degree mode, I will get the right answer. So sine inverse 0.83. I got 56.09. If I'm rounding to the nearest tenths place, instead of keeping it at a 0, I'm going to go up to 1 because of the 9 that came next. So this is 56.1 degrees. It's tricky because we haven't seen problems like this, but it's actually quite easy because all you have to do is type in the inverse of whatever decimal that is. So this one, same type of problem. We're going to do cosine inverse of 0.97. I'm using cosine because they gave us cosine of 0.97. So cosine inverse, second cosine, 0.97. I got 14.06. So I'm going to go 14.1 degrees. All right, over here we have tangent of A is 1.43. So to find the angle measure of A, I'm going to go tan inverse of 1.43. Let's see what it gives us. 55.03. So I don't need to round up with the 0 because the 3 next to it just leaves it there. But in order to show that I did look at the tenths place, it's a good idea to put 0 right after it, 55.0 degrees, to show that we are looking for the accuracy that we had below. Let's move on to 25. I think this is showing up in the screen okay. Solve the triangle below. When they ask us to solve a triangle, that means they gave us a few pieces of the triangle, but we need to find all the other pieces. So all of the pieces would be all 3 side lengths and all 3 angle measures. They gave us 1 side length and 2 angle measures. And since it's 90 degrees, we can use our trigonometry to help figure out the rest of this. I'm going to start by finding the measure of angle N. I know that the 3 angles of a triangle added together need to equal 180 degrees. So to find this, I'm going to take 180 minus 90 minus 44. And this is some easy calculator work you could do if you want. 180 minus 90 minus 44, and I end up with 46 degrees. Okay, now we need to find 2 sides. If they had given us 2 sides of the triangle, then we could find the third using Pythagorean theorem. But since they only gave us 1 side, we need to use trig ratios to discover it. I'm going to use the 44-degree angle since that's what they gave us, and since I make mistakes, it's possible I made a mistake there. You don't have to do that, but that's what I like to do. This side with the 12 is opposite the 90-degree angle, so it is the hypotenuse side. If I want to find side NP, I can give it some letter, we'll call that side X. It is opposite the 44-degree angle. So this one is opposite, and then I can call this side MP. I could call it Y, and it is adjacent to the 44-degree angle. Okay, let's go ahead and solve for opposite first. We can do either one, but opposite is fine. So I'm going to use opposite and hypotenuse. That's the only other side I know. Which trig ratio uses the legs, or the lengths, the sides, opposite and hypotenuse? And if you remember back to SOHCAHTOA, it is sine that uses opposite over hypotenuse. So we're going to say sine of 44 degrees is equal to whatever the opposite is divided by 12. Let's remember for a second what this means. And that is that all right triangles that have a 44-degree angle are similar to each other. So you can remember that before we used to set up two ratios and set them equal to each other to solve. We're doing the same thing here, except your calculator has had this data placed into it. So it's remembering the sine of 44 fraction or ratio. So we can just use that our calculator remembers to solve for the missing piece that we have here. Since the variable is on the numerator, I'd like to get that alone, so I'm going to multiply both sides by 12. So when I type that into the calculator, I'm going to say 12 sine 44. 12 sine 44. I can close the parentheses or not. It will give me the same answer, which is 8.3359. They said round to one decimal place, so I'm going to go 8.3. And that's side NP, 8.3. Okay, to find side MP, we're going to use adjacent and hypotenuse, and that is the cosine ratio, uses those two. So the cosine of 44, our calculator has memorized, well, it has been programmed to have cosine 44 put into it, that whatever fraction is made by the two adjacent and hypotenuse sides of a 44, 90, 46 degree triangle. It has those plugged in, so we can use that data to help us find the missing piece. So cosine is asking for adjacent over hypotenuse. We said adjacent was y, hypotenuse is 12. Since y is the numerator, we're going to multiply both sides by 12. So y is equal to 12 cosine 44. And we get 8.63, means that I don't need to affect the 6, so it's 8.6 is going to be our measure there.